Welcome to our introduction to the engineering design cycle. The purpose of this overview is to introduce engineering students to the cycle and even to refresh the professional engineer on this formal version of engineering design. In this module, we'll describe the formal steps involved in engineering design. To others, engineering design may seem like a magical process that allows us to seamlessly leap from a fabulous idea to a working prototype that works the first time, no less. And then the magical process might progress to accolades and applause from a welcoming design review audience with no further need to integrate and redesign. Unfortunately, engineering design is rarely that simple or magical. As engineers, we are often obligated to follow a much more formal process that provides justification, backup, and other evidence for our choices in pursuing a particular design. Just in case the prototype doesn't work, as we thought, or just in case our audience and potential customers in a design review are not as informed or as enamored with our design as we are. With that thought in mind, let's move forward to look at the formal engineering design cycle. The engineering design cycle has almost as many versions as there are types of smartphones in the world. But despite the many different ways of expressing the engineering design cycle, the cycle contains some common elements that guide the engineer from start to finish, and then back to start again, as the repetitive but rigorous nature of the design cycle ultimately produces a design that is both functional and profitable. There are many similar design cycles, some of which are appropriate for the classroom, such as the simple design cycle shown here, and others which are more useful for specific fields of engineering or types of products. The one we show here in particular is generalized enough to suit most engineering design projects found at the undergraduate engineering level. So let's move forward with the simple version of the engineering design cycle. In the first stage of design, it's very important to do more than rely on common sense to identify the problem we are thinking of addressing through our engineering efforts. Otherwise, we may end up with yet another product flop, such as those shown here. Designs that, while well-intended, may have no purpose whatsoever, or that may not sell at all to any sizable number of customers anywhere in the world. Clearly, these two examples represent extremes of product failure, but it's all too easy to rely only on our own intuition or common sense in identifying a problem to be solved, and finding out much later that common sense wasn't enough to identify a useful problem. The design team provides some buffer against the pitfalls of our own common sense and internal perspective, and forces us to be specific about who, what, and why. But the next step in the design cycle will be essential to provide some assurance that the idea and problem we have chosen in a particular engineering design cycle is a viable one. In this next step of the design process, we are obligated to use multiple and credible sources of information to justify the problem we have identified to pursue in the design cycle. Adding to our own ideas with accompanying market research is just one way to increase our understanding and help to justify the choice of designs that can lead to products which will expand globally or nationally. In this example of market research, we see that investing in a problem associated with technology Y is certainly more lucrative and worthwhile than persisting with technology X, because the growth in technology Y is likely to allow more products and more competition than technology X in the future. Researching the need can rely on market research, but often does and should involve using the peer-reviewed literature as well. Trade magazines or surveys conducted by nonprofit organizations can also be used to provide evidence that there are indeed customers out there that will need the product we are endeavoring to design. Once we have identified an engineering problem and researched the need for it to be solved, we can move on to the next part of the engineering design cycle. In this phase of the cycle, we will pursue multiple solutions to the problem that we have both identified and justified. In order to do so, however, we first have to clearly define the specifications for the design before we try to identify specific solutions. Some design specifications are make or break requirements for a functional product, and some specifications are desirable constraints for the design to meet. For example, it may be absolutely necessary for a carbon monoxide sensor to detect potentially fatal levels of carbon monoxide, but only desirable for that sensor to do it while dissipating 1 watt of power or less. With these specifications in mind, we can begin to propose solutions, from the incremental to the wild and crazy, considering the full space of design as we proceed through this step in the design cycle. Once the specifications are clearly identified based on real-world considerations, all design solutions should be considered, regardless of how boring or eccentric we may think they are. However, only solutions that meet the specifications should be taken seriously, and the adjustment of specifications to match our favorite design should be done with great caution, and very rarely at that. Once we've narrowed our design solutions to those that meet the specifications defined at the beginning of this step in the cycle, we can evaluate the surviving designs by looking at what others have done. Looking at what has failed and what has succeeded in research and development efforts or in similar products gives us further insight into which of our design solutions is ultimately the best to pursue. In the end of this step in the design process, we will have a block diagram or similar layout of what the best solution will look like in hand. And although this particular stage in the design process is not finalized, it provides a clear roadmap as to how to move forward. In the following steps, we may find it necessary to go back to our design solutions and our selection process. So it is as important to document these initial steps in engineering design as it is to document a working design or prototype towards the end of the cycle. Now, armed with the best solution in our pockets, we can proceed to making a prototype of our design. A prototype, by its very definition, may not contain the exact same materials, parts, or format as the final product. However, it should look similar enough to a targeted product and function well enough in the same context to convince the stakeholders or customers that it's a successful design even as early in the design process as the first iteration of the design cycle. The goal of a prototype is to provide data and demonstration that makes the design convincing. No matter how awesome or clever a design, a messy or haphazard prototype is simply not convincing. Fortunately, in modern day, we have access to very sophisticated prototyping techniques, such as three-dimensional printing, to produce a convincing prototype. But sometimes the old-fashioned techniques involving foam core, cardboard, or similarly simple materials will also do the trick. Once the prototype is visually convincing, it must also be functionally operational and convincing, so we can move on to testing and evaluating it. After constructing a prototype, it's important to test it in a way that with proper design of experiments not only proves the functionality of the device, but does so in a way that the functionality is reliable and marketable for potential customers, both those who are enthusiastic about our design and those who may be more skeptical. This step in the design cycle often involves backtracking. Sometimes it may be necessary to go all the way back to researching the need for the problem because of the results of testing and evaluation. As we are all human, nothing will change the fact that it is difficult to move backward in the design process, but nevertheless we must be ready to do so if Test and Evaluate sends us in that direction. Being prepared for the likelihood that we'll have to backtrack and rethink our solutions is as important as being prepared to move forward. Whether we move backward or forward, we will have to collect and present data that justifies our decision. The way we present data can often be a make or break issue, and careful design of figures, graphs, tables, and other presentations of data is as critical at this stage of the design process as collecting the data itself. If we are ready to move forward after testing and evaluating, it is usually time to allow our design to be reviewed. The data that's presented at this phase and used to demonstrate the functionality of the design should be presented in such a way that it matches the technical sophistication of the audience, avoiding presenting too little as well as too much data and information. Each figure in a design review should clearly tell a story. Otherwise, we may have just turned it over to our audience to make up the story on their own about the design and its potential success. It's very important to remember at this phase of the design cycle that presenting all the details is not the assignment, but rather selectively filtering all of our design process up to this point must be done in order to distill the design and its successes and failures to a few nuggets that lead the audience to the next desired phase of the design. Depending on how far along the product is in the process, feedback should be welcome and redesign should be attractive to the design team. Clear feedback, no matter how unexpected, will go a long way in smoothing out the next iteration of the design cycle. It is during the final phase of the design cycle that the design team will decide what to do with their feedback and how to proceed. The team will realize that there are many opportunities to go back to the drawing board, and the challenge will be to prioritize feedback from the most important to the lesser important, so that moving forward is both fruitful and efficient. In conclusion, in this overview, we have looked at the engineering design cycle in just one of its many forms and learned that it may look simple, but stepping through it is often susceptible to iteration, backtracking, and a variety of other complicated maneuvers. Although we may jump around in the process, going forward and backward as the design merits, it's important to know that we should never really skip any phase of the design process, because what we skip is likely to have major and undesirable consequences over the long haul. The nonlinearity and lack of predictability in the design cycle does not at all mean that it's not methodical or rigorous. Rather, it is a product of a real team operating in a real world where things don't always work as originally envisioned. Thank you for joining us on this brief overview of the engineering design cycle. We certainly hope that this overview has been helpful to understanding engineering design at a big picture level, and that you'll join us again as we look at each phase of the cycle in more detail.